Now we're going to go over how to add or multiply and divide fractions. So let's start with multiplying. So first of all, this is going to be a negative times a positive because 3/4 is negative and 1/2 is positive. So negative times a positive is going to be a negative. And then I look to see if I can cross cancel. Now guys, cross canceling is just reducing, but in an X. So from here to here and here to here, exactly like we were doing before. Okay, so I look at the 3 and the 2. Are there any numbers? Is there a particular number that can go into both of these evenly? There is not. So then I look at the 4 and the 1, same with that. So once I'm sure there's no cross canceling can be done, then I just multiply up the numerators. So 3 times 1 is 3, and then I multiply up the denominators, and 4 times 2 is 8, and we are done. If for some reason we can reduce our answer when we've been multiplying or dividing, then it means we had some cross-canceling that we should have done. When we get our answer for multiplying and dividing, there should be no reducing needing to be done. Okay? So let's just do a bunch of examples just to go over this. -2 times 3. So first I'm going to look and I'm going to say, oh, multiplied by. Negative times a negative is a positive. So, and I don't need to write that. Then I'm going to look at the 2 and the 3. Remember, in an X. So 2 and 3. Any number that can go into each of those evenly? There is not. Then I'll look at the 5 and the 2. Same there. So all I have to do now is multiply up my numerator. So 2 times 2 is 4. And then multiply my denominators. 5 times 3 is 15. And I'm done. That's it. It's easy as that. 3/4 times 3/8. So I always look at the signs first and then the numbers. So positive times a positive is a positive. So I don't need to worry about that. 3 and 8 going in the X, so across from each other diagonally. There's no number that can go into both of those evenly, so then I'll look at the 4 and the 3. No number that can go into those evenly, so now I just multiply up my numerators. 3 times 3 is 9, and 4 times 8 is 32. Make sure you guys know your multiplication tables. You really need those because I won't let you use calculators on this. So let's try this one. Okay, first of all, I look at this and I say, well, positive times a negative because 15/28 is positive and 6/5 is negative. So positive times a negative is a negative. Now I don't need to worry about that. Let's see. 5 can go into itself once and 5 can go into 15 3 times. 6 can't go into 28, but 1 and 6, 2 and 3. 3 can't go into 28, but 2 can. So 2 can go into 6 3 times, and 2 can go into 28 14 times. Now notice how when I cross these out, whatever number's left over, I write above or below. If we're writing them out to the side, I have found that students get themselves all mixed up. So if you write it above and below, students almost never get these mixed up. So just a habit you might want to think about cultivating. Now I've done all the cross canceling I can, so I just multiply up my numerators. What's left is 3 times 3, so that's 9. And I multiply up my denominators. 14 times 1 is 14, and that's my final answer. Let's do some more. Which one was that? Okay. So now we've got 12 sevenths times 7/24. First of all, I've got a positive times a positive, so positives we don't write. Let's see. First of all, pretty easy. 7 can go into itself once, both ways from bottom to top. And let's see, 12 can go into itself once and into 24 twice. All I need to do now is, and this is where writing your numbers above or below is really important, because if you do not write those ones above, very often people get confused and end up on one like this will give me this as an answer. That's not what we're going to get here. Multiply your numerators. 1 times 1 is 1. And the denominators 1 times 2 is 2. There's a huge difference between 2 and 1/2. Would you rather have $2 or would you rather have 50 cents? Okay? So be really careful. And if you leave those ones, you're much more likely to make sure that you get that correct. Okay, and 9/20. All right, so negative times a negative is a positive, so I'm not going to write that. Let's see, 9 can go into itself once and into 18 twice. Okay. I can't do anything with the 11 and the 20. 11's the smaller of those two, and that's 1 times 11, and that's it. And 11 doesn't go into 20, and remember, we don't do ones. So that means I've done everything. So 11, all the cross-canceling I can do. So 11 times 1 is 11, and 2 times 20 is 40, and that's our answer. Now let's talk about dividing. Now remember, we cannot divide fractions, so we are going to do something called copy.flip. Now, this is a fraction divided by a fraction. You may not be used to seeing it this way, but in algebra, and as you get in higher and higher math, this is mostly the only way that we write it. It's the exact same as if you were writing it like this, divided by 5/8. Okay, the top one is our first one, and the bottom one is our second one. Okay, so get used to looking at it like this, guys. All right, so in division, we're going to do something called copy.flip. Just get used to that, copy.flip. As soon as you see division problems, a fraction over a fraction, copy.flip. What that means is I'm going to take the first fraction, the top one, and copy it exactly like it is. Then I'm going to change this divide sign into a multiplying sign. And then I'm going to take the second one, or the bottom one, and flip it. Now, we just do exactly what we were doing a minute ago with multiplying. So first I'm going to look in negative times a positive is going to give me a negative. So now I don't need to worry about that. Let's see what I can cross cancel. Nothing between the 3 and the 5, but 4 can go into itself once and into 8 twice. Now I just multiply up the numbers. 3 times 2 is 6. 1 times 5 is 5. There's my answer. Let's do some more. 5/6 divided by 10. Well, guys, this 10 is the same as 10 over 1. Now, I said never write anything over 1, except for right now. We need to do that so we can do our problem. By the time we get to our answer, though, if we end up with 1 in the denominator, we do not write it. But now I can say I've got a fraction over a fraction. So I just needed to change the denominator into a fraction. So now I'm going to do copy.flip. So copy the first one exactly like it is. Dot, change the divide to a multiply, and flip my second one. Now there's nothing I can cross cancel between the 6 and the 1, but 5 goes into itself once and into 10 twice. And so first of all, I got a positive times a positive, and in the numerator 1 times 1 is 1, And in the denominator, 6 times 2 is 12. And that's my answer. How about this one? I've got negative 9 divided by negative 9/16. Well, again, I want to think of this as negative 9 over, we'll do this a different color, over 1, because I can put anything over 1 and it's still exactly what it is, remember? It's that thing, and then divided by 9/16. So let's go ahead and do our copy.flip. So we've got negative 9 over 1 dot, change divide to multiply, and now I can't have two operators next to each other, remember? So I have to put, because multiply times a negative are two operators, and then I flip the bottom one, 16 over 9. So look at that, 9 goes into itself once. Negative times a negative is a positive. 1 times 16 is 16, and 1 times 1 is 1. But again, we never write our final answer with a 1 in the denominator. Okay? Think I can get a couple more in here. So 3 over 10 divided by 4/5. So 3/10 divided by 4/5. Copy.flip. So copy the first one exactly like it is, dot, change divide to multiply, flip. My second one, a positive times a positive is a positive. 5 goes into itself once, into 10 twice. Can't do anything with the 3 and the 4, so multiply my numerator. 3 times 1 is 3. Multiply my denominator. 2 times 4 is 8. Okay. 2/3 divided by 1/6. So copy.flip, 2/3, change divide to multiply, 6 over 1. Positive times a positive is a positive. 3 goes into itself once, into 6 twice. 2 times 2 is 2. 1 times 1 is 1. But again, that ends up being a whole number. Now, how about this, guys? Anything divided by 0. So in other words, if 0 is in the top, then our answer is 0. But if 0 is in the bottom, I cannot divide anything by 0. So our answer is undefined. Let's think of this. If I'm checking this, I would take my answer and multiply it by my denominator, because multiplication is the opposite of division. So 0 times 5 equals 0. Is that what we got in our numerator? Sure is. So anything where 0 is on the top, the answer is 0. But if I do this, whatever answer I have here, if I did, let's say it's 0 times 0, that does not equal 5. If I said it was 5 times 0, that does not equal 5. So whenever 0 is in the bottom, think of it as underneath. It's undefined. All right, there you go.